So now we've reached level two, which is all about functions. So just as a brief overview, this chapter we're going to talk about everything that defines what a function is and some basic parent functions that we're going to need to know what the graphs look like. So we'll figure out what a function is. We'll talk about function notation, domain range, the vertical line test, what even and odd functions are, increasing, decreasing, local max and mins, average rate of change, which is going to be super, super important when we get to calculus next year. So the more we emphasize it early enough, the more you'll know. And then know this library of functions. So I've included, I wrote the page for the book on here, but I've also included the graphs that we should know. And we'll discuss more of this as we move on to this chapter. So moving into level 2.1, we're going to get into the basic definitions of a function. So the first things first. With functions, the first thing we talk about are relations. And that's just a comparison between two objects. And by objects, we can call it define it even more vaguely, two sets of information. With a relation, we have an input and we have an output. The input is what we plug in, and the output is what we get out. So it doesn't have to be a mathematical relation to have something that has an input and an output. But specifically, especially in math, when we define a function, so we say let x and y be two non-empty sets. That means there's stuff inside them. A function from the set x to y is a relation that associates with each element of x. So every element in x goes to exactly one y. So a function, each element in x goes to exactly one output, because whatever we plug in, we want to get only one answer back out. We don't want to have to make a decision on where the answer is going to be. And we'll see more of that in just a second. So the domain is all the possible inputs and our range is all possible outputs. So let's try an example and see what this means. So looking at this image, we have a relationship between the states and the number of representatives for each state in the House of Representatives. So it's asking, is this relation a function? It's a relationship between two things, and we can see the whole thing we're looking for is, does every input go to one output? So Alaska goes to 1, Arizona goes to 1, California goes to 1, Colorado goes to 1, Florida goes to 1, and North Dakota goes to 1. So this is, yes, this is a function because all states have exactly one number for their representatives. Now, this thing that might confuse some people is I look at this chart and I see that Alaska goes to 7 and Colorado goes to 7. That's okay. We can have multiple elements in our domain or in our input go to the same number in our range. But we can't have one element go to two different ones. So that's the key thing. So let's look at the next one and see if it's any more clear what a function is. So again, pictured our relations. Tell if each one is a function or not. I'd highly suggest you pause it and look at these on your own, but we're going to jump right to that. So if you haven't already, take a little time to try this on your own. So with A, each one of the things from the level of education goes to an unemployment rate. So all of these go, so every input goes to one output. So we say this is a function. The second thing says state the domain and the range. So the domain is the set that includes no high school, a high school diploma, some college, and college graduate. What I'm writing right here, these are called braces. And we use these braces to represent sets. So we use these for sets of things. If we're looking for the range, our range is going to be the unemployment rates. So all of our outputs. So we have 8.5, we have 5.0, we have 4.2, and we have 2.7. That's everything in our range. Let's look at B. We've got fast food sandwiches, and then they're fat. So let's see if this is a function. This goes to 1, this goes to 1, this goes to 1. We go to 23 here, 33, and 23. So every part of our input goes to one output. So this is a function. And I'm going to write the domain are the sandwiches, calories. We can see the list here. And our range are all of these numbers. It's the fat. So that's 19, 29, 24, 33, and 23. We could organize this list numerically, but that's for a little bit later. Last one. Is this a function or not? Our carrots go to one price, 73 goes to 1, 74 goes to 1, 76 goes to 1, 0.86 goes to 2. Because 0.86 goes to two different values, I don't want to have to make that choice, so this is not a function. So let's flip it over and see what else we have. So the next page, looking at example 3, it says determine whether each relation represents a function. If it is a function, state the domain and the range. So again, we're looking for, if we wanted to do each one of these problems, we're looking for x and y. For every x, there's one y value. So the x's, we have 1, 2, 3, and 4. And the y values, we have 4, 5, 6, and 7. For this one, for A, every x goes to exactly one y. So this is a function. My domain would be 1, 2, 3, and 4. And my range would be 4, 5, 6, and 7. That's my inputs. Those are my outputs. For B, I'm going to do the exact same thing. So let's label these, and I'll do these in a little bit different color so we can keep track of it. So for B, I'm going to make the exact same chart. So I have 1, 2, 3, and 6 as my inputs, and my outputs are 4, 4, 5, and 10. Now the whole definition of a function, every x goes to exactly one y. So each input goes to one output, so this is a function. Even though 1 and 2 both go to 4, that's okay. So our domain is 1, 2, 3, 6. My range here is 4, 5, and 10. I don't have to write 4 twice because it's already included. For C, if I did the same thing for C, if I made my t-chart, x and y, I've got -3, -2, 0, 1, and -3. So I already see that I might have a problem here because -3's repeat. So I go 9, 4, 0, 1, and 8. And here's the problem. -3, if I plug that into my whatever my function would be, I get two possible answers. So I have to choose. And I don't want to have to choose. So this is not a function. So moving on. Example 4. How do you tell if this equation is a function or not? Well, we want to, for every input, we have exactly one output. So no matter what number we picked for x, we're going to get exactly one answer out for y because we're multiplying that number by 2, then subtracting 5. So this is yes. For example 5, this should look familiar. This is the equation of a circle, and I'm just going to graph that for you guys. Remember, we did this in level 1, so this circle should look familiar. It has a center of the origin and the radius of 1. And if I solved this for y, just like the other one was, I would get y squared equals 1 minus x squared. And if I took the square root of that, I would have plus or minus the square root of 1 minus x squared. So we could test a point to see what happens. If I test a point and let's say we plugged in 0, I would have y equals plus or minus the square root of 1 minus 0, which is plus or minus 1. Well, for one input, I have two different outputs, and that's not what we want. And just like our graph, we can see here that these 2 points kind of match up. And because we have something, and we'll get to this later, that's the vertical line test if you remember. This fails the vertical line test, and this is not a function. All right, a few more things. Function notation and evaluating functions. So this is what we're going to spend the majority of this year working with. Function notation we use to name different things. So we usually read this statement, it should say, as y equals f of x. So this is y equals f of x. Or a function with a variable x, f of x, where x is the independent variable and y is the dependent variable. So y depends on x. X we can choose whatever we want. Y will be always the output. X is going to be what we plug in. Y is what we get out. That's what this picture is supposed to mean. So when we look at these problems below in example 6, it says, given the function f defined by f of x equals 2x squared minus 3x, evaluate. Whenever you see this word, all that's telling you is plug in a number. So let's try some of these out. F of 3. And wherever I see an x, I'm going to replace it with 3. So I have 2 parentheses 3, because I replaced the x with 3, squared minus 3 times 3. So now I just do order of operations. So 3 squared is 9, times 2 is 18, minus 9. So I get 9. How about f of x plus f of 3? Well, f of x is just this equation. So when I write out f of x, I just write 2x squared minus 3x. And we've already found out what f of 3 is, so I'm just going to write plus 9, because that's what f of 3 is. If I'm looking for 3 times f of x squared, I want 3 copies of 2x squared minus 3x. Not 3 copies, but I want 3 times one of those. So I'm going to distribute that. which gives me 6x squared minus 9x. Last one, I have f of 3x. So with f of 3x, wherever I see an x, I'm going to plug in 3x. So again, I'm going to write 2 parentheses 3x squared minus 3 times 3x. This is a little different than just plugging in 3. When we plug in 3x, I obviously get, this is going to be 9x squared. So this is going to be 18x squared minus 3 times 3 is 9x. So that's what we're going to get a little bit into evaluating. So we have one more page and then we'll be done for this level. So the last page, a couple quick other ones. It says, use your calculator to find the following values. F of x equals x squared, and I want to find f of 1.234. So I left my fancy graphing calculator at home, but I wanted to show you that even if you just have your phone on you, you can still do these things. So if I'm trying to find f of 1.234, all I want to do is square 1.234. So I type in 1.234, and then I'm going to hit this x squared button, just like that. And I'm going to leave my answer in terms of 3 decimals. So, well, I can write the whole thing out. 1.522756. And I'm going to clear that. G of x, so a different function, is 1 over x. Find g of 1.234. So what's really nice about this is I have a reciprocal function right here. And if I just hit that button, that's 1 over 1.234, which is 0.8104. Let's leave it to 4 decimals. All right. Last couple ones. These are the ones that are kind of scary, that a lot of people struggle with. So hopefully we'll try to make this as easy as possible. Domain of a function. The domain of a function is all possible x values. So when we say all possible x values, what we want to look for are any restrictions. Things that I cannot be. Because if I have a restriction on my domain, then I can't use that number. So let's look at a couple examples here. First off, if I look at this function, which is a polynomial, it doesn't matter what number I pick, because any real number will give me an answer back out. So my domain for this, for A, is going to be all real numbers. And just so we remember, this symbol is the set of numbers that includes all real numbers. So we're going to use set notation this year, and it's just a bold R. How about B? What is the domain of B? Well, we should remember from fractions that we can't divide by 0. Because we can't divide by 0, with this fraction, we don't want 0 in the denominator. So we don't want this to be equal to 0. Well, that's x plus 2, x minus 2, not equal to 0. So x cannot equal negative 2, and x cannot equal 2. So the way we would write the domain for this function would be the set of all numbers of x such that x is not equal to plus or minus 2. Either way, we can write the domain like this, or you'll see sometimes in the book that they write the domain like this. These braces again mean sets, and I've added one new symbol. This vertical line right here means such that x cannot equal plus or minus 2. Last one for finding the domain. we should remember that we can't have a negative number underneath the square root sign. So we want 4 minus 3t to be greater than 0. Greater than or equal to, because we can be 0. So now we just go about solving this. So what I'm going to do is I'm going to add 3t to the other side, divide by 3. So this says 4/3 is greater than or equal to t, or t is less than or equal to 4/3. That's my domain. If I'm not a number smaller than 4/3, this is going to make it negative. Likewise, just to reiterate this, our domain would be t such that t is less than or equal to 4/3. Last few. Operations with functions. We've been doing these for a while. We're just actually naming it right now. So if I give you two functions, if it says f plus g of x, all we're going to do is add the two functions together. So that would look like 1 over x plus 2 plus x over x minus 1. Now, when we look at a problem like this, you'd be like, okay, I'm done, right? Well, we can add these. We need to get a like base or a common denominator. So the common denominator here would be x plus 2, and the common denominator here would be x minus 1. These are all things I expect you to be able to do. These are freshman year skills. So I would be left with x minus 1 over x plus 2, x minus 1, plus x squared plus 2x, distribute the x, over x plus 2, x minus 1. So then last bit, we can add like terms. This gives you x squared plus 3x minus 1 over x plus 2, x minus 1. If we had subtraction, that would look like 1 over x plus 2, because that's f of x, and minus x over x minus 1. So when we already did this work, all we have to do is change the sign in between now. So that's x minus 1 over x plus 2, x minus 1, minus x squared plus 2x over the denominator. Now the trick that I always like to do is when we're subtracting a quantity, I'm just going to distribute that negative. So that would leave our answer here with negative x squared. X minus 2x is negative x minus 1 over x plus 2, x minus 1. Likewise, when we're doing addition, we can do multiplication or division. So with multiplication, that would look like 1 over x plus 2 times x over x minus 1, which is really easy. We just multiply the tops, multiply the bottoms. So that's x over x plus 2, x minus 1. With division, that's probably the one that you guys will be your least favorite. It would be 1 over x plus 2 divided by x over x minus 1. And we should remember that when we divide by a fraction, it's the same thing as multiplying by the reciprocal. So that's x minus 1 over x, which would give us x minus 1 over x times x plus 2. So hopefully that's a nice little refresher on the definition of functions, and I expect you guys to start these problems first thing in class.